Hey guys, this will be the second video of our two-part series of dealing with the properties of logs. So in this video we're going to be talking about the inverse property and the change of base formula, both of which aren't too hard to understand. Okay, so the first one we're going to deal with is the inverse property, and it's pretty straightforward. But we know that the inverse of an exponential is a log, and the inverse of a log is an exponential. Well, that knowledge is going to come into play when we're dealing with the inverse property, because what the inverse property states is if we have a log and an exponential both with the same base, so for example, in this situation right here, we have a log with a base b and an exponential with a base b, well, they're simply just going to cancel each other out, or you could say undo each other, okay, because they're inverse of one another and they both have the same base. So in this case, they'll simply just cancel out, leaving you with that x value. Okay, likewise, if you have an exponential with the same base as your log, right, being raised to a log, well, same deal here, they're going to simply just cancel out or undo each other, and you'll just be left with your x value here. Okay, so that is the inverse property. So let's do some examples here. So starting out simple, if we have log base 8, and then we have 8 to the 3x plus 1. Well, based on the inverse property, we can see that, okay, these are simply going to cancel out, right? So we can simply just cancel these out, and we'll be left with 3x plus 1. All right, that's it. That's the inverse property. Let's try another example here. So if I have log base 5, and then we'll have 125. Well, think about this. How can we rewrite that 125? Okay, well, we can rewrite it as this. Log base 5, and then we can say 5 to the third power. Well, again, look at our inverse property here. We know that this is simply going to cancel, and we're left with 3. All right, so that is our answer here, 3. Okay, let's try one more. So we have 2 to the log base 2, and then 27. So again, using inverse properties, same base, okay, they're simply going to cancel. All right, in this case, your answer here is going to be 27. All right, so pretty straightforward. That is the inverse property. Now, let's go over the change of base formula. All right, so let's go over change of base formula. So let's go ahead and erase this. Change of base. Change of base formula. So what I'm going to do, I'm going to write it out using algebra first. All right, and then we'll do some problems. All right, so let's go ahead and write out. So the change of base formula looks like this. We have log, and then we have base x, okay. And we'll have log ax all over log ab. So when you're using the change of base formula, right, it's always going to be done in your calculator. And what it's saying is, if you're giving a log, all right, you can evaluate it in your calculator, okay, by putting it in like this. So for example, a is going to be a base of 10, so just log as it is in your calculator, and whatever x is and whatever b is. Okay, so let's go ahead and look at the first example, so this will make more sense. If you have log base 4, we have to the 8, right? If you want to evaluate that real quickly in your calculator, well, you're simply just going to do log of 8 all over log of 4. All right, that's a change of base formula. again, when you put in log in your calculator, it's already going to have that base of 10, right? So just be aware of that. So we're going to do log of 8 divided by log of 4, and we get 1.5. All right, so our answer here is 1.5. Okay, let's try one more problem here. Let's do log base 9, and let's do 27. Okay, you want to evaluate that real quick. Same thing, log of 27 all over log of 9. Alright, when we do that in our calculator, we get log of 27 divided by log of 9. And we get, again here, 1.5. Okay, so that is the change of base formula, as well as the inverse property.